Preparing for a data scientist at Wells Fargo interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you approach building a machine learning model to detect credit card fraud? I would begin by clarifying the objective, label definition, prediction horizon, and cost of errors. For fraud, I would prioritize recall while controlling false positives. Then I would inspect leakage, missing values, class imbalance, and temporal splits. I would compare a baseline with logistic regression and tree-based models, calibrate probabilities, validate stability across time and segments, and document assumptions. In banking, robust monitoring and human review often matter as much as headline accuracy. While answering, cover business objectives, fraud label definitions, class imbalance, temporal validation, leakage prevention, precision recall trade-offs, probability calibration, monitoring, and human investigation workflows. Question 2. Write a SQL query to identify customers whose transaction spending increased by at least 30% month over month. I would aggregate transactions by customer and calendar month, then use lag to retrieve each customer's previous monthly total. Conceptually, the query computes current spend minus prior spend, divided by prior spend and filters for values at least 0.30. I would exclude null or zero prior balances, clarify whether refunds are included, and use a consistent time zone. Finally, I would test boundary months and duplicate transaction records before presenting results to stakeholders. Make sure to cover monthly aggregation, customer-level grouping, window functions such as lag, handling zero or missing prior months, date boundaries, and avoiding division by zero errors. Question 3. How would you handle a highly imbalanced dataset for a banking classification problem? I would not automatically oversample the minority class. First, I would quantify the costs of missed events and false alerts, then establish a simple baseline. I might use class-weighted loss, carefully applied undersampling, or synthetic methods inside each training fold. Evaluation would emphasize precision recall curves, recall at a feasible alert volume, calibration, and segment stability rather than accuracy. The final threshold should reflect investigation capacity and risk policy, not merely maximize F1. In your answer, discuss business costs, stratified or temporal sampling, class weights, resampling only within training folds, suitable metrics, threshold tuning, calibration, and operational review of false positives. Question 4. Explain how you would validate a model used for loan default prediction. I would split data chronologically so training precedes validation and testing, because random splits can overstate performance. I would ensure all features are available before the lending decision and prevent borrower-level leakage across partitions. Besides AUC, I would examine precision recall, calibration, default rate lift, stability over vintages, and subgroup outcomes. I would also test stress scenarios and document limitations, assumptions, approval criteria, and monitoring triggers for model risk review. Be sure to mention out-of-time validation, borrower-level leakage, reject inference considerations, calibration, subgroup performance, stability metrics, economic impact, and documentation for model risk governance. Question 5. What is the difference between correlation and causation, and how would it affect a banking analysis? Correlation means two variables move together. Causation means changing one produces a change in the other. For example, customers using financial advice may show better repayment, but motivation or income could explain both behaviors. I would avoid causal claims from a predictive model alone. When experiments are impractical, I would consider matching, difference in differences, instrumental variables, or regression controls, then state assumptions clearly. That distinction prevents expensive policy decisions based on misleading associations. Focus on confounding variables, selection bias, reverse causality, randomized experiments, quasi-experimental designs, controls, and cautious interpretation of observational customer or financial data. Question 6. How would you explain a complex machine learning model to risk, compliance, and business stakeholders? I would explain the model at 2 levels. First, I would present its purpose, inputs, validation results, error costs, and monitoring in business language. Then I would show global drivers and individual-level explanations using methods such as SHAP, while emphasizing that explanations describe model behavior, not necessarily causality. I would include counterfactual examples, limitations, version documentation, and human override procedures. Clear evidence and consistent terminology build more trust than technical jargon. Make sure to cover audience-specific communication, global versus local explanations, feature effects, counterfactuals, limitations, documentation, reproducibility, and alignment with regulatory expectations. Question 7. Describe how you would detect and prevent data leakage in a predictive modeling project. I would define the exact prediction timestamp and restrict every feature to information available before it. Common leakage includes post-default collections fields, target-derived aggregates, and fitting imputers or encoders on the full dataset. I would use time-based splits, entity-aware partitioning, and pipelines that fit pre-processing only on training data. Suspiciously high-performing features deserve investigation, not celebration. Finally, I would compare offline results with a realistic backtest and production data availability. In your answer, identify target-derived features, future information, post-outcome fields, pre-processing leakage, duplicate entities, temporal controls, pipeline isolation, and review methods for suspiciously strong predictors. Question 8. Which metrics would you use to evaluate a customer churn model for a financial product? The right metric depends on the retention action. If outreach capacity is limited, I would examine precision and lift in the top-ranked customers. If missing a likely churner is costly, recall matters more. I would also use ROC-AUC for imbalanced outcomes, calibration for expected response rates, and profit or saved revenue estimates after treatment costs. I would validate performance across customer segments and choose a threshold jointly with marketing, compliance, and operational teams. Discuss the decision objective, class prevalence, precision, recall, lift, ROC, calibration, top K capacity, retention economics, subgroup behavior, and threshold selection. Question 9. How would you design an experiment to measure whether a new banking feature improves customer engagement? I would define a measurable hypothesis, such as increased weekly active usage without increasing support contacts. Eligible customers would be randomly assigned at an appropriate unit, usually customer level, with treatment contamination minimized. I would pre-register one primary metric, guardrails, analysis windows, and stopping rules, then estimate sample size using baseline variance and a minimum meaningful effect. After the test, I would report confidence intervals, practical impact, segment effects, and any implementation issues. Be sure to mention hypothesis definition, randomization unit, treatment contamination, primary and guardrail metrics, power analysis, experiment duration, statistical significance, and practical impact. Question 10. What steps would you take to ensure fairness in a credit or lending model? I would involve compliance early and understand which attributes may be used, audited, or prohibited. I would examine missingness, proxy variables, approval rates, calibration, false positive and false negative rates across relevant groups, and intersectional segments. If disparities appear, I would investigate data quality and feature necessity before testing mitigation methods. I would document trade-offs, validate the final model independently, provide adverse action explanations where required, and monitor fairness after deployment. Focus on legally permitted data use, protected group evaluation, proxy variables, disparate impact, equalized error analysis, explainability, alternative models, human review, and ongoing governance. Question 11. How would you forecast cash withdrawals or branch demand for Wells Fargo? I would first define the forecast horizon and granularity, such as branch day or ATM hour demand. I would inspect trend, weekly patterns, holidays, pay cycles, weather, promotions, and local events. Baselines like seasonal naive forecasts should precede gradient boosting or time series models. I would use rolling back tests, report prediction intervals, and evaluate both error and stockout or cash delivery costs. Sparse branches may need hierarchical or pooled models rather than independent forecasts. Cover forecasting granularity, seasonality, holidays, trends, external drivers, hierarchical aggregation, backtesting, uncertainty intervals, operational costs, and fallback behavior for sparse locations. Question 12. Tell me about a data science project where your analysis changed a business decision. In one project, a team wanted to contact every customer showing reduced activity. I analyzed historical behavior and found that broad outreach produced many false positives. I built a transparent propensity model, validated it with time-based splits, and partnered with operations to test a focused top decile campaign. The pilot improved response per contact while reducing workload. I learned that adoption depends on workflow design, clear explanations, and measuring business outcomes alongside model metrics. Make sure to structure the response with context, measurable objective, data challenges, analytical approach, stakeholder collaboration, quantified outcome, and lessons learned. Question 13. How would you investigate a sudden drop in a production model's performance? I would confirm that the performance decline is real by checking labels, metric code, sample size, and reporting latency. Next, I would compare feature distributions, missingness, category frequencies, prediction scores, and outcomes against a trusted baseline. Segmenting by product, geography, channel, and customer type can expose localized failures. I would inspect upstream releases and data contracts, decide whether to roll back or adjust thresholds, and document root cause plus preventive monitoring. In your answer, cover metric definition, data quality checks, schema changes, feature drift, concept drift, segment analysis, pipeline failures, rollback decisions, and root cause documentation. Question 14. When would you choose logistic regression over a more complex model for a banking use case? I would favor logistic regression when interpretability, stable coefficients, fast scoring, and straightforward governance are important, especially for regulated decisions. It provides probabilities and directional effects, but it may miss nonlinear interactions. I would establish it as a baseline, add sensible transformations or interactions, and compare it with boosted trees using time-based validation. If the complex model provides meaningful lift without unacceptable explainability or stability costs, I would justify that trade-off explicitly. Discuss interpretability, regulatory review, linear assumptions, sample size, nonlinear relationships, performance comparisons, monotonicity, calibration, and the cost of operational complexity. Question 15. How do you handle missing values in customer and transaction data? I would first determine whether missingness is random, operational, or informative. A missing income field, for example, may reflect a process issue or customer segment. For numeric variables, I might use training set medians or model-based imputation with an indicator. Categorical fields can receive an explicit unknown category. I would preserve time ordering, avoid fitting transformations on validation data, compare sensitivity across strategies, and monitor missingness rates because they can signal upstream failures. Be sure to mention why values are missing, missingness indicators, training-only imputation, categorical handling, temporal behavior, business rules, sensitivity analysis, and monitoring after deployment. Question 16. How would you use Python and pandas to prepare transaction data for modeling? I would load data with an explicit schema, normalize timestamps and currencies, remove or reconcile duplicates, and validate keys before joining tables. Using pandas, I could group transactions by customer and rolling time window to create features such as count, amount, and recency. I would separate feature generation from target creation to prevent leakage, wrap transformations in a reproducible pipeline, and add assertions for ranges, nulls, and row counts. Large datasets may require SQL or distributed processing. Focus on reproducible pipelines, typed schemas, date-time normalization, aggregation, joins, deduplication, leakage-safe feature windows, validation checks, and memory-conscious processing. Question 17. Explain precision, recall, and ROC-AUC using a fraud detection example. Precision is the share of flagged transactions that are truly fraudulent. Recall is the share of all fraud that gets flagged. Raising the threshold usually improves precision but lowers recall, while lowering it creates more investigations. ROC-AUC measures ranking across thresholds, but can look optimistic with extreme imbalance, so I would also inspect PRAUC and precision at an operational alert volume. Calibration is separate. It asks whether predicted probabilities match observed fraud rates. In your answer, define confusion matrix outcomes, relate metrics to investigation capacity and fraud cost, explain threshold effects, and distinguish ranking quality from probability quality. Question 18. How would you build a customer segmentation strategy for a bank? I would start with an action the bank wants to take, because segments should support decisions rather than exist for visualization. I might build behavior-based features covering balances, product usage, transaction frequency, and digital engagement, then scale appropriate variables and compare clustering methods. I would assess silhouette scores, stability over time, segment sizes, and business interpretability. Finally, I would profile each group, test whether actions differ meaningfully, and avoid unnecessary sensitive attributes. Cover business purpose, feature selection, scaling, behavioral versus demographic variables, clustering choices, validation, stability, interpretability, actionability, and privacy considerations. Question 19. How would you prioritize competing data science projects at Wells Fargo? I would score initiatives against expected business or risk impact, customer benefit, regulatory importance, confidence, effort, data readiness, and dependency risk. A model with impressive potential but unreliable labels may rank below a simpler control with immediate value. I would define success metrics and a small discovery phase for uncertain projects, then review priorities with business, technology, compliance, and model risk partners. This creates transparent trade-offs instead of choosing solely by technical novelty. Make sure to discuss customer and risk impact, regulatory urgency, feasibility, data readiness, expected value, dependencies, effort, stakeholder alignment, and measurable success criteria. Question 20. What questions would you ask before deploying a machine learning model into a banking production environment? Before deployment, I would confirm the decision, users, latency, data contract, feature availability, security controls, privacy requirements, and model ownership. I would verify independent validation, explainability, fairness checks, approval status, and reproducible artifacts. Operationally, I would define monitoring for drift, data quality, performance, calibration, and business impact, plus alert thresholds, retraining criteria, rollback procedures, and human escalation. A model is production ready only when its controls are as clear as its predictions. Discuss data contracts, ownership, latency, security, privacy, explainability, validation approval, monitoring, retraining, rollback, human oversight, incident response, and documentation. If you are still with us, congratulations! You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.